Alright guys, we're going to talk a little bit more about scaling and shifting. We're not going to actually write any programs that'll draw. We're just going to look at the math involved. So there's an in-class assignment. If you refresh your Dropbox, you'll see O, scaling shapes. Open that Word document up. So this document needs to be trimmed considerably. It's pretty much the same document that we were working on Thursday. A little bit better drawn. Some of the things are better explained. So in order to scale, we have to understand the XY coordinates. What is the XY coordinates of that dot? Yeah, that's at 10:30. So we're going to come up here, fill in 10 and 30. And this is in class O. We can kind of skip this one because we already did it, but what is the radius of that circle? Looks like it goes from 25 to 40. So that's got a radius of about 15. And its origin is at 40, 20. Scrolling past the bear head. We did the bear head already. We did the programming already. Shifting coordinates. Our bear is tiny. It's in the wrong place. We want it in the center of the window. And then later on, we want it blown up larger. So shifting. So to shift is to modify the coordinates in such a way as to move the drawing to a different position on the screen. And when we say modify, we mean by adding or subtracting shift values. So in the diagram below, we want to shift the green circle so that its position is that of the pink circle. And the way you do that is you pick some part. Here I'm using the origin as we were doing in our turtle program. And you get the coordinates for those and you take the differences between the coordinates. So 30, element C1 is at what position? Its origin, not its radius. I mean its center. What are we going to call that at? Let's do it here. So that would be 50, 30. As long as you were consistent, it would work fine. I mean, we could go from the center just as easily. In fact, the center would make it easier. So if we were going to go from the center, that would be 40, 30. Let's go from the center. And then what's the center position of circle C2? Yeah, that one's easy. 0, 0. So to shift C1 to C2, we're going to have to go minus 40 each on the x-axis to get it there, and then we're going to have to go minus 30 on the y-axis.
It's not a 10.
Pardon me?
C2, 10, 0.
I'm spacing out. Yeah, if you go by the origins, it's at position 50, 30 and position 10, 0. But then somebody suggested the center, so I went with that, which would make it 40 to 0, 0. Either way works. The difference between 50 and 10 is 40, and the difference between 30 and 0 is 30. Are we good? If that doesn't make sense, let me know. Okay. So its shift x factor would be minus, not factor, a factor is a multiply. Its shift x value would be minus 40. Its shift y value would be minus 30. And I think that's probably what we went with in the bear. I don't recall. So to scale, instead you have to find a multiplication factor. So here we have a line that we're going to increase the size of to make it fill more pixels on the screen. And right now it's going from 2020 and -20, -20, but we're going to make it go larger. We're going to make it go 4040 and -4040. Now it's easiest to do this, oh dadgummit, I forgot to put that black line where it was supposed to go from 0, 0. Anyways, mentally move that line up. Okay, so the easiest way to do it, if the x and the y scaling factors are the same, even if it's not positioned as 0, 0 like this one is just to take the height and divide it by the height of the other one. Or the width and divide it by the width of the other one. So on page 11, I really don't think this document has 29 pages. I wonder what's going on with that. On page 11, what we're going to do is what is the height of the red line? It's given below, but if we had to eyeball it, what's its height? 10, 20, 30, 40, 50, 60, 70, 80. So it's got a height of 80. The other one had a height of 40. So in order to transform the green line into the red line, its scaling factor would be 2. Now sometimes you don't want to scale in a square, Sometimes the scaling factor would not be the same and you'd need a scale x and a scale y. But I'm assuming that everything we have is already of the correct aspect ratio, and so we're just going to have one scaling factor. So the way you calculate the scale is the second value, the intended value, divided by the starting value. So the height of 2 divided by the height of 1. What's that lead to a scaling factor of? 2. So does that make sense how we shifted our position to be in the middle, and then we could calculate the scaling factor by comparing the height of the new shape to the height of the original? Well, I hope it makes sense because we're going to get a little bit more practice. Okay, so here's homework problem number 1 on page 13. Or not homework problem, in-class problem. Decided to do this in class. I want to move the Space Invader from that position to that position. And then I want to scale it larger. All right, so let's just pick a coordinate. Which corner do we want to go with? Let's go with that upper corner. What is the coordinate of that upper corner?
56.
Yeah, it's 50, 60. X, Y. And then what is the X, Y coordinates of that upper corner? Looks like it's about, yeah, -5,
5.
comma 5. So what are the shift values in this case? It's a difference of 45 and a difference of 55. So I didn't give you all the columns here. I could have. I could have given you an X and a Y, and you take the difference between the two.
Shouldn't the X one be 55 as well?
It might be. Let me look.
Yeah. Plus 50 minus -5 is.
Yeah, you're right. Silly prof doesn't know what a negative number is. The difference between that and that, according to our mathematically astute students, and I believe them, now that I look at it, it's 55, 55. Bless you. And what's a scaling factor of this? Well, what's the height of the original invader? Looks like 10. What's the height of the new invader? 10, 20, 30, 40, 50. Does that make sense? If 10 is that big, then it would be 10, 20, 30, 40, 50. Pardon me?
I was looking at the wrong way.
Oh, yeah, if you looked at the wrong one, that'd be a problem. Okay, so if you take the height of the intended shape and divide it by the height of the original shape. The intended shape was 50. The original shape was 10. So what was its height? I mean, what's its scaling factor?
5.
Yeah, 5. I think I'm going to put a comment here. You don't have to do this, but this is. I'm going to insert columns to the left, and I'm going to say that nah, I'm not going to mess with that. Y'all understand it. Okay, here's another one. Take a little bit of a stab at doing it yourself rather than just typing what I'm doing. I don't mean that pejoratively. I just mean that that's what I would be doing if I was in the class. Just typing along. So think about what the shift X and the shift Y values are going to be. Who's got a shift X in their mind? So we're going from negative 30 to positive 30 to negative 10. So that would be a minus 40. You were doing Y.
It'd be positive. No.
Well, to go from here to here, to move green to pink, you're going to subtract values. And if I typed in positive numbers up here, that was a mistake. Because to go from here to here, we had to subtract 55. And to go from there to there, we had to also subtract 55. So to make your homework correct, scroll back up to page 13 and make those numbers negative. Okay, so we went 40 or minus 40 to get the green one to move there. How many pixels on the Y?
Negative 20.
Yep, negative 20. And what's his scale factor?
5.
Yeah, for a minute I spaced out. He is 10 tall. No, he's 20 tall, and this guy's 100 tall. So 100 divided by 20 is a scaling factor of 5. Where's my last picture? There was supposed to be one more. The whole thing is duplicated again. That's why we have so many pages. Okay, on the last page, page 29, and I'm sorry for having all those inserted pages there. Good thing this is in class. I'll clean it up for the people doing it at home. What is the shift value, X and the Y, for this guy? Well, I'll give you a hint. The shifting value, no shifting value is required because the image is already centered. So in this case, the green is the original size, and for some reason I'm making him smaller rather than larger. So that implies something about the scale factor. Instead of being a number greater than 1, like 2 to make him twice as big or 3 times as big, it's going to be a number less than 1. It's still going to be a positive number, but so what's the height of the original invader? 60. And what's the height of the new invader? 20. So, to calculate the scaling factor, you divide height of new shape by height of original shape. So that's 20 divided by 60, which is 1/3, or 0.333. You don't have to do this, but I'm deleting a bunch of pages. Well, that didn't work. I'll fix this later. You can just turn it in as is. It'd make better reference material if it wasn't goofed up like this. Yeah, go ahead and upload it. I totally hope that makes sense. I wasn't going to give you any homework problems on it, but maybe I should, because there's going to be a question or two like that on the exam. Should be pretty clear though. You just figure out how many pixels, X and Y, you need to do to center them, and then what you have to multiply them to get to his final size. Does anybody use Word for a living and know how to delete a mass number of pages all in one fell swoop without just highlighting them? I can't think of a way. Just highlight the first page and keep scrolling? Is that what I heard?
I'd start at the last page, the last page you want to delete.
Yeah.
And then scroll all the way up.
Okay.
So like that very page. You have to highlight like the bottom line of the page. And then
Okay.
scroll up.
I thought I had, and it turns out I didn't.
I did.
This one?
Oh, really? Well, I'm not as clever as you. I'm not doing it. Hey, here we go.
Or controller.
Well, that was select everything.
All right. That's better at least.
So all we're doing is the right?
Yeah, all we're doing for this is we're just uploading the Word doc back into the O assignment. Because we modified our Turtle program last time to do scaling. So if we go back and we look at the program we wrote last time to reinforce it, we had a shift X value, we had a shift Y value, and we had a scale of 5. And so that roughly positioned the bear into the middle of the screen. I think it did a good job of it on the X-axis. I'm not so sure it did a good job of it on the Y-axis. Yeah, he could have been shifted a little bit better. 30 rather than 40 probably on the Y-axis. Yeah, that looks better. So you can do that algorithmically in your program. If you can calculate where the bear is, draw a square around the whole shape, conceptually, not on the page. And then take the largest values and the smallest values of that square, and then adjust it to the largest and the smallest values on the screen that you could draw. So you could do that algorithmically. Or in a program, a drawing program like Paint or Illustrator, something like that, you make it responsive to user input so that as they're scrolling the mouse wheel up, it multiplies the factor, and as they scroll the mouse wheel back, it reduces the factor. I'll totally clean that up. Did everybody get that? Pardon me, Cyrus?
On problem 3, did you put anything for the shift X or shift Y? Did you like put a 0?
It's in the same place, so just put 0, 0 or leave it alone. Either's fine. Okay, I'm opening the head first PDF. Go ahead and download it. It's awfully hard to scroll up and down inside that little window, that preview. So as your programs develop, so do your data handling needs. And when you have lots of data to work with, using an individual variable for each piece of data gets really old really quickly. So like if you had 1,000 names, payrolls to add up, you wouldn't want X1, X2, X3, all the way to X1000. So programmers employ some rather awesome containers known as data structures, lists in our case, to help them deal with lots of data. More times than not, all the data comes stored from a file. So how can you work with data in your files? Turns out it's a breeze. So they say. The annual Codeville Surfathon is more popular than ever this year because there's so many contestants. The organizer asked you to write a Python program to process the scores. Eager to please, you agreed. The trouble is, even though the contest is over and the beach is now clear, you can't hit the waves until the program is written. All right, enough of the back talk. So what we want to do is after the judges rate the competitors, the files are stored in a file called results.txt. There's one line in the file for each competitor's score. You need to write a program that reads through the lines, picks out that score, and then works out the highest score in the Surfathon. It sounds simple, except for one small detail. You've written programs to read data from the web and from the keyboard, but we haven't written any code that reads from a file yet. So what we're going to do is we're going to open the file. And then once you're in the file, you can process the file with a for loop, just like we were processing a list of data. And I know we haven't written any homework with a list of data, but we've done an in-class assignment or so where I was lecturing about using a for loop to go through a list of data. Probably ought to make a homework assignment for it as well. So the call, here's how you open a file. There's a word called open, and then you feed it a file name. And if you don't give it a path, which is those things with the slashes, then it'll open the file in the same directory. If you do give it a path, like C:\\, whatever, slash whatever, it'll open that file in the specified directory. So this returns what's known as a file handle, and the file handle is used by the program in order to process the contents of the file. So after you open the file, Python makes it really easy to process a file line by line, way easier than in a lot of languages, because you just use a for loop. So here's what the code is going to look like. Open the file, results.txt, and put the handle in result_f. And then for each line in the result f, print each line. And then close each line. Let's do that. Let's make a program that will open itself as data and display the contents of the file. So go ahead and create a new file. Save as, get it out of the Python directory and call it readfile.py. Just remember that name. If you give it a different name, you have to remember that name. So I'm just going to call it FI, short for file, rather than result underscore FI. I guess I could call it the whole word file as long as it's not a keyword. Yeah, that doesn't look like a keyword. It ought to be safe to use. File is equal to open, and I'm going to type in the same name as my program is because I'm going to open my own file and print it out. And between the quotes, I need to put the name of the file, which I called readfile.py. And now, for every line of data in the file, print read in quotes, comma, and then that line. And then we're going to close the file. Why do you close the file? Because if you keep it open, nothing else can modify it. If you're trying to back up a file and it's open, you may not be able to back it up, something like that. So generally your programs want to open the file, do their duty, and then close the file as quickly as possible. So then we're going to do file dot close. Let's see if it works. There it goes. It's reading our file. If you didn't get it all typed in, we'll adjust this so that you can see it. It's reading our file in line by line. Now, why does it have that word read in front of it? Just because I printed that word out. You know, if I deleted that part out, then it would print it without that word read in front of it. I just wanted to kind of differentiate between the data and what we're printing. Also, what looks kind of weird is that we're getting extra lines between those. We can call a function that would remove the extra lines at the end. That stuff's called white space, and white space consists of tabs and spaces and returns. So we don't really like the white space. Maybe we could use the strip keyword in order to remove those spaces. Let's try that. Line is equal to line dot strip. I'm going to give that a try. You may not want to type it until I get it to work. Yeah, there it went. Okay, much better. Now it printed it out without the blank lines. So what we did is we stripped it of the white space at the beginning and the end, which is not totally cool because we lost our indentation. It cleaned it up at the end, but it also cleaned it up at the beginning. So our output no longer has the indentation that it had before. You know, this line is equal to strip, and the one underneath it should have been indented. So out of curiosity, I'm going to see if there's an R strip command, which will only strip the end. So I'm going to add a letter R in front of that strip. Much better. It left the indentation on the beginning. I only wanted to strip stuff off the right side of the line, not the left. So I'm going to add some comments here. Open the specified file and store the file handle in a variable named file. And again, the variable name is unimportant. I could call it Fred, I could call it Gaga, whatever. And then what's next? Use a for loop to process each line of data in the file. I'm going to add a comment above the strip. Strip the right side of the data, removing spaces, character turn line feeds, tabs, etc., which is all known as white space. And then lastly, print the line out. Print our data, and at the close statement, I'm going to comment that and say you should close files immediately after you are done with them, so that they are not locked by the operating system. Does that make sense? If you ever had that happen, you're trying to move a file to another directory, or to another drive, and it says, cannot move file or cannot delete file. It's because that file's open. Now, if you write a program like this where the last thing that happens is the file close, well, really, it would get closed anyways when the program is done. But what if this program is going to loop 1,000 times and then it's going to go do something else and draw a graph and whatever? If that, that could take a long time, and the file would be open the entire time. And if your backup program was running, it might not be able to copy that file. Okay, so that's very similar to the program that they're going to want us to write. What they want is a file full of numbers, and they want to get the highest score. So they're going to be adding those numbers to a list most likely, or at least keeping track of the highest number as they do. Yeah, that's what they're going to do. I would do it slightly differently, but that's okay. I want to do this the way I would do it, not the way they're going to do it. Okay, so we need a we need a data file. We're going to call it results.txt. So do new file, do save as, and call it results.txt. Leave the E off. And just type some numbers in it. You don't have to do my numbers. I'm going to make my largest number 101. Okay, so there's my data. That's results.txt. Results.txt, it needs to be in the same directory as the program we're about to write. It doesn't matter how many lines of numbers you have, it doesn't matter what the values are, just know what your largest value is so that when it runs you can determine if it's correct. Then create another program, another file, and call this one, I don't know, results.py. Oh great. Results.txt, Python renamed it to the with the extension results.txt.py. We'll just cope with that. That's not ideal. We'd like for it just to say .txt. So I'm going to close my results.txt.py file, and I'm going to go find it out in my directories and rename it results.txt. So it's the one that should have about 1 kilobyte of data in it. Rename it to results.txt. Take off the .py at the end. And it'll give you some warning about, are you sure you want to do this? Yes, we're sure. All right. I apologize for idle not giving it the extension that I requested. There's probably a way to get it to do that, but that time it didn't work. Okay. Now I can double click on that file and it'll open it up in Notepad. Those are my scores. That's the results.txt file. And I'm going to write another program to read this data. But first I'm going to comment it out. Open the file. Use for loop. add each line of data to a list.
Are you in the results one?
This is a results.txt file. Sorry, I need to close that. That's results.txt, and this is a new program.
Wait,
And then when we're done with our for loop, we're going to use the max function to print out the highest score. So file is equal to open results.txt. If you never successfully renamed your file, add .py to that file name. Now we need to declare an empty list so that we can start adding things to it. Scores is equal to square brackets, empty list. And now as we read the file, we're going to start adding data to it. For each line of data, in the file, colon, let's strip the line first. Line is equal to line.strip. This time I'm stripping both the before and the after because, you know, all it is a series of numbers and I don't care if anything was indented or not. Now let's convert that into a floating point number or an int. Either way would work. X is equal to the floating point version of that line, and then add, is it add or append? I always get this wrong. Append X to it. Let me run that, make sure I got it right. Okay. Now we have a list of scores. Let's just print the scores. Print scores, and then let's find the max. I'm going to call it max score because max is a keyword. If you type the word max, it highlights it in purple or whatever. So max score is equal to the max of the scores list, and we can print that out. Maximum score is, comma, max score. And mine came out with 101, which I commented earlier was going to be my maximum score. So why do you save data in a file? Called persistent data, you know. You wouldn't have to want to type in the American census data every time you wanted to run a report on it, you know. 400 million households, type them all in each time. No way. Instead, that data gets written out to a database so that it can be processed over and over. That's the same idea as a file, you know. A database is a file, effectively. You wouldn't want to type in your resume every single time you wanted to print it. Instead, you save it to a file so you can reload it back. So we're using persistent data here. We're using a file to store our list of scores so that we can print the maximum score. Just for grins, while I'm wandering around, checking to make sure, if you've already got it working, make it also print the minimum score. And the minimum function is just min rather than max.
Yeah.
I mean, you have something?
I still have it, so I can change it, but. And if you want, you could probably get this part here, language, and stuff next. So come over here, new file, save, as, change the text, the type to text files. And then delete that second dot txt. That's just 4 times. Now you can probably check it out here, get rid of that dot py. Cool. If you want, we could get this in a file named .txt.
See, that's what I said, you know, that,
Yeah, my mistake was not to choose text file, and then so of course everybody else made my mistake. Now you can go back and. Right, yeah. Let me see what it is. No touch file or directory, results of text. Well, this is in a directory called. So let me see what this is. I don't know if it's in the same directory. Yeah.
That's still not fine. You sure it's on desktop?
No, it's not on the desktop. You have it on the desktop?
Showing some directories.
Okay. But this is in.
It just had to be in the same directory.
In the folder.
Program.
This is not good.
Yeah,
In
let's
the
go.
folder.
Still saying written, I think, still saying.
Well, yeah.
All right, so we
I
started
need
typing
something
it.
to move here, and this is.
This
in
program
the
reads
folder
in a
right
file
now.
called results.
Oh, it's in the
Text
folder on the
process
desktop.
numbers out of it.
Okay, yeah, but it's gotta be the same place, because you're not
It
telling
is.
us twice.
Yeah, just close
It
it,
is.
do it
They're
in a
both in the
file,
same folder right now. They're not either one on the desktop.
call it scores.
See, that's not the class assigned.
Yeah.
That's where they were.
They're both in there?
Yeah. This is the class assigned folder right here. That's where that just was.
Go ahead.
Well, don't wanna do that.
Also, we're gonna make a file for the numbers. So, new, that is numbers.
It's because of,
Okay.
whatever.
Save that as
Oh,
a
it was
text
open.
file.
I think it was open.
Use text file and call
Where's
it
that?
results.
Okay. Oh, all right. Whatever.
Save. Let's make sure that file is there. Results. So good, okay, it's there. Okay. So now you need to enter the program that's shown on the left side of the screen as they are. A little bit different than it was before. We all good on the side room? Okay. Do you need help with the scaling homework? Okay, okay. All right, guys. Have we done the instructor review yet?
Yes. Yeah.
We did? Okay, y'all already said great things about me? Cool. All righty. So how about we spend like 5 or 10 minutes after class? Can you wait until then to work on that? Okay, cool. Well, if you need help with the scaling program too, you got the file input to work? Okay, cool. Okay. So I hope you see what it's doing. It's kind of neat that the for loop can read in an entire line of data just with this one command, for line and file. And what did we say the for loop was used for? It's when you know that the program is going to have a discrete set of data rather than just loop until a condition is met. So it's going to have a discrete set of data. It has a file to step through. Just like when we had a list of data, we could use a for loop to step through a list of data. Or a range. Remember the range command? Range, 1 comma 100 would count from the numbers 1 to 99. In this case, it's counting through all the data in the file. And the data doesn't just have to be a series of numbers. It could be considerably more complex than that. But for our first file, a series of numbers is fine. And then, as usual for the head first book, they go nuts with the assignment. Sorry, Davian, I covered up the program over here. Tell you what, I'll print this out. Okay, if we typed it in the way they'd said, they show getting an error. And the problem that they did is they didn't convert it to a float or an int. We did that. They also don't add the values to a list. Instead, they have an if statement that says if the line is greater than the highest score, then set the highest score equal to that line. But why rewrite code if there's a max function? Okay, so here they have something that has not only got scores, but it's got names in front of it. Oh, sorry, I should have got that for you. Okay, so let's modify our program so that it has names as well as scores. So find your text file again. And then we're going to split the data. I think I showed the split data. The split data causes a line of data to be turned into chunks of data that are placed in a list. That's easiest to see if we just do it within idle. So in the shell, I'm going to do this. A is equal to my name is Mud. Now I'm going to split A. So A dot split says my, comma, name, comma, is, comma, Mud. Which is perfect because once we add names to our text, to our scores, we'll be able to skip them. We'll only need like one piece of the data, not all of them. Okay. So Joe made 100, John made a 40, Sally made a 90, Terry made a 60, his sister Terry with an I made 100, Susan made 101, whatever, just pick your own names. But it's not going to be expecting first and last names, so for now, let's just do first names. Larry. Sam, and Sally. Now if we run our program, it's no longer going to work because it's got this extra stuff in it. It's no longer purely numeric data. And here's what it says. Could not convert a string to a float. Well, that's because the string was Joe followed by 100. We need to split the data before we turn it into a float. All right, I want to do this in such a way that it's easy for you all to see the changes that I'm making. I'm going to make a new variable underneath line is equal to line.strip that says data is equal to line.split. And then underneath that, we're going to pull out the specific value. Well, first let's print that data line just to see what it does, see what it looks like. So these are my two new lines of code. It's still going to be broken. So if you don't want to type this in and you want to wait for the final result, that's fine. But here's what it did. It printed Joe, 100. You see that? So when you start counting a list, what is the first element's number always? It's not 1. It's 0. So this is going to be element 1. Right? Remember, we always start counting as 0 in computers. So that's element 0, that's element 1, and if there were any more, it would be 2, 3, 4, and so whatever. So now that we have that, we can go back in and make the final change to our program, which is that we don't want to convert that entire... I'm going to take the print statement out. We don't need that. But where it says x is equal to float, we need to make sure that it accesses the second element of the data. So these are our two new lines right here, 1 and 2. And we took, and this is actually a change. That float line is a change, not a brand new line. So add this line, insert that line, and then modify this line. You know, it'd be really neat is if we could store that person's name as well, and then print out their name as well as their score. And they're probably going in that direction, and I probably have veered away from that direction using what I just did. Excuse me while I eyeball this. We may have to change our code to match theirs more completely to do this, where we can print out the person's name. Well, they didn't go towards printing the names. Instead, they went towards printing the top 3 values. So we can do that. We could modify our score to print the top 3 values rather than the top value. So we already have a list called scores. Let's sort the data. Now our program's getting longer than 1 page. I'm going to delete some comments. It's going to make it harder to read, understand what it's doing. But I'm deleting the comments so I can get it all on 1 page. And down here where we say print maximum score, before we get the score, why don't we sort the data? So what we're going to do is we're going to say scores is equal to scores.sort. That will sort that list. then we don't even have to use max anymore because we know that the maximum score is just the first element in the list. So underneath, well, I'm going to run it as is right here to make sure it's working before I start getting fancy. Yeah, that didn't work. Okay. So this is going to say scores sub 0 because it's the first element in the list. And then we're going to print out the runner-up and the second runner-up. So second runner-up, or no, we're going to call this first runner-up. And that's the element number 1. And then the second runner-up is element number 2. So, kind of our entire last block changed. So everything from there to there has been modified. Well, what do you know? I blew that. There we go. It's sorted in reverse order, though. It found the first, second, and third, but it's going from minimum to maximum. Do you remember a index value to get to the end of the list rather than the beginning of the list? It's kind of weird and it only works in this language, but if you give it a -1, it goes to the last value of the list rather than the first. And then if you give it a -2, it goes to the second last. And if you go to -3, it goes to the third last. Now we're doing this so that we print the last 3 values and not the first 3 values. There we go. Now what they do is they reverse the list after. So I think this is going to be it for our scores program. I'd like for y'all to get this to work. And then we're going to eyeball real quickly some extra functions that work with lists, which are shown on the next page of the head first document. Okay, if your program is not working, then between the split line and the float line, add this statement: print line, comma, data. Then when you run it, you can see what your data looks like, and we can see if it's what we expect. Now mine, since I got it working, is what I expect. Do that as I'm coming back to help you.
Oh, there you go.
Okay, now that line doesn't have a name preceding it. Did you modify your results.txt file to have names in it? We'll save it. Save.
My runners.
Where did you save it? Did you save that?
Printed this, but didn't do that.
It needs to be in the same directory as this one. Except we
Go back to your text file. Yes. Go ahead.
Okay. Oh, not that, huh? Sure you know, it wasn't saved.
Okay. Export document file and remember it's out of order, but
Parentheses after sort. That's a function call.
oh,
Yep,
yep. So that.
that'll do it.
There we go.
Good deal.
Thanks.
And this is,
You can upload this to O if you want. I'm not going to count off if it's not there.
Okay.
We'll get those, so-
That's pretty cool. I mean, I'm assuming those numbers are right.
Yeah.
Yeah, excellent. Well, we all good? Put it in there if you want, if you got it done, you may as well. Nah, not as your credit. We all did it. But at least you can find it, you know. You can go back and find it later if you didn't take it home with you.